Hello and welcome to the next section of Unit 10. All right, so the first thing you're going to have to do is you're going to have to change the equations if they are not already changed. I might have already changed them for you. But if they don't look like the ones I've written here, then change them. All right, so again, these are going to be some short notes. And this section is going to seem like it's more difficult than it really is. And after we're done, you might be thinking it's too easy, but no, it's really not that bad. So a baseball is thrown into the air with an upward velocity of 30 feet per second, so I don't really care about that. Its height is h. So this is what I care about, what the variables represent. So h represents height in feet after t seconds. So t represents time in seconds. And then it's given by this function. How long will it take the ball to reach its maximum height? And then what is the ball's maximum height? So how long will it take? And then what is the ball's maximum height? So I'm just going to go ahead and tell you that when we graph these, if you throw a ball up in the air, throw it up there, then it lands, what shape graph does this look like? Hopefully you're saying either U-shape or parabola. So it's a parabola. So when I'm trying to find the maximum height, where on a parabola is the maximum or a minimum? Whenever we use those two words, what point has a maximum or could be a minimum? But in this case, it'll be a maximum. Hopefully you're answering vertex. So if I find the vertex, then I will know what the maximum height of the ball is and how long it took to get there. This equation is already in vertex form, so it's going to be pretty easy for me to find the vertex. So the vertex is this number, but change the sign, so 40, comma 8,000. So notice that t is in the place of x, h is in the place of y. So our vertex is going to look like this. So whatever t is, and then whatever h is. So t is going to be the time, h is going to be the height. So here we have t and h. So this tells us that the time it took to get to the maximum is 40, so that's in seconds. So the answer to the first question is 40 seconds. The maximum height of the ball, height, h, is 8,000. So 8,000, it's in feet. Yeah, feet. So our answer is it took 40 seconds, and then the height it got to, the maximum height it got to was 8,000. So that's all you have to do. So in example 4, a golf ball is tipped in the air from a small hill at an upward velocity of 50 feet per second. Its height, which is represented by h, and then we're using feet for height. After t seconds, so t represents seconds, is given by this function up here. What is the maximum height the ball reaches, and how long does it take the ball to reach its maximum height? So the reason I'm emphasizing maximum, because when we are looking at a parabola, where do you find the maximum? At the vertex. So to find the answer to these questions, when they say the word maximum or minimum or highest point or lowest point or most or least, it's always talking about the vertex. So you're going to find the vertex and you'll have your answer. So if I find the vertex, which in this case is going to be 2, 64. So again, t is in place of x, so this is our t value. H is in place of y, so this is our h value. So this tells us it takes the ball 2 seconds to get to its maximum height, and the maximum height is 64 feet. And that's it. And then finally, the last example. So a punter kicked a football into the air upward at a velocity of 62 feet per second, its height h, so h represents height, and we're using feet. T represents time in seconds. So how long will it take the ball to reach the maximum height, and then maximum, what is the maximum height of the ball? So if I find the vertex, I'll pretty much have my answer. So the vertex of this equation is 10, change the sign to positive, 500. This t, normally there's an x there, so t is replacing x. H is where y normally is, so this is my h value. So that means my answer is 10 seconds. It took the ball 10 seconds to get up to its maximum height, and then it reached a maximum height of 500 feet. So if we did graph this, this would be the vertex here. So like on our graph, say it looks something like this. This would be 10, the x value would be 10, and then the y value would be 500. So that's what it's saying. So that's it for the notes.